Okay, thank you very much. My name is Melissa Dempsey. I'm going to show you how to design a steel shell shed structures using Autodesk Robot Structural Professional 2021 version. I'm going to use the Eurocode standard. So to do this first, I'm going to open the Autodesk Robot Structural Professional 2021 here. Now click this shortcut icon. Now Autodesk Robot Structural Analysis Professional 2021 is opening. Here now the program is open. As I'm going to use a Steel 3D model, now just click this frame 3D design. Here now the program is open. In order to model the structure, first I have to set the code parameter. So to do this, just go to the tool menu and go to the job preference. Here there are lists of options that you are going to uh, modify. Here the dimension. Now the unit and the format has to be set in such a way that you are going to use in your model. So the dimension is here. This is the structure dimension in meter, and the section dimension centimeter, section property in centimeter, steel connection dimension in millimeter, or the diameter of RC bar in millimeter, reinforcement area in centimeter square, crack width is in millimeter. Or this you can convert to other dimension that you wanted to use. And here there is also a force. Similarly, you can take the default setting as it is, or you can convert as you like. And other here the displacement is in centimeter. All these values are set in defaults. Here the unit editions also here, the material. Now the Eurocode, as I'm going to use the Eurocode standard, so I can use the Eurocode, or just you can select the standard from the down drop list here. So and still here in the case of steel structure is also just you can select the grade of the steel that you are going to use. So if you wanted to use 235 to 75 or 355, just you can select what you like. But as I'm going to use S355, just click this one. Now the concrete you can, as I'm going to use also C3037, just select this one. Aluminum, in the case of aluminum I'm not going to use aluminum, so omit this one, and the timber omit this one. And here there is also a modification uh, button here. So the material definition can be modified here. The youngest modulus of the steel structure is 21,000 megapascal, or the Poisson's ratio is 0.3, or you can change this one also. So this material definition is associated with the materials that you are going to use. So in this case I can take as it is. In the case of concrete also here, in the case of aluminum here, in the case of timber here, you can modify all these parameters and others. For example, if you wanted to use the material other than steel, concrete, aluminum or timber, so you can put the mechanical property of that material. So now click OK here in the database. If you want to use the material database here, still in timber section, I'm going to use the Eurocode material database. But if I wanted to import also the material from others catalog or others standard, so just click this one, add a new database to the list. Now when I click this one, here there are many standards from the drop down list, so you can select what you want. For example, if I wanted to import some materials from the Australian standard, so I have to click Australian standard and click OK here. Australian's material database are imported into my working profile. So the vehicles, the Eurocode, the standard, the Eurocode, the building soil, and this is the soil database is just like this, and the bolts, the Eurocode, anchor bolt. Here it is also the Philippines for code, and the reinforcement bar. This is the Eurocode. The wire fabric. It is the Eurocode. So. The design code here, the design code is here is still our the aluminum structure. I have to use the Eurocode, and steel connections, the Eurocode, timber structure, the Eurocode, RC structure, the Eurocode, the geotechnical, the Eurocode. Or you can convert, you can change the standards that you are going to. For example, if I wanted to use ACI code, I have to click those three dot lines here. Now select the standards that you are going to use from here. For example, if I wanted to use the British standard, I have to click this one. Or if I wanted to use the for example, the here okay, the ACI code here, this is the American standard, so I can click this one. So if I click this one, now let me show you here. I just go to this one. So here, this is the American standard. I think it is not American. Okay, this is the American. This is the British standard. So you can select the code as you want, and the load, the code combination. This is the Eurocode, the wind load to Eurocode, seismic load to the Eurocode. All just you can select the code that you are going to use. So the structural analysis here, just take as it is, the worker parameter, and just take as it is, the meshing as it is. So now click OK. So after defining the code parameter, I have to define the axis definition. Just to do it, click this one. So as I am going to use 5 grid lines in X direction and 6 grid lines in Y direction, just here the Cartesian. I'm going to use the Cartesian, or if you want to do the cylinder, just click cylindrical. And if you wanted to use arbitrary dimension, you can click this one. But in this case, I'm going to put the Cartesian. That means the rectangular grid spacing systems. Now click add, because the starting point is 0, and now here that is the position is 6, so the distance is it is 6. Now I'm going to use the 5 gray lines, so just the number of repeats is I think it is 5, so like add, you know here starting from 0 to is 36, and when we come to the y, now click add here, so similarly it is 6, number of repeats it is 6, and the distance is 6. Now click add. Now it is 42 in y direction. And then here, in order to save time, let me reduce this into for example into 4. Okay, sorry, okay, sorry, it's little. Okay, 6. Okay, it is now 6. It is 6. Okay, no. It is 0. Number of 6. It is 0. Now it is 0. Okay, now click add. And here 6. Number of repeats it is 6. And the distance is 6. Add. That is 42. And in z direction, click add. And it is 0. It's already set. Now it is 8. Add. So it is 10.5. Add. Okay, here it is 1 to 3, the numbering, and in y it is BC, and in z it is as the value. So now click apply. Here the grid lines are defined. So the second step is defining the section. Here to do this, now click the bar or section definition icon here. Now I'm going to define the new material. So this is the section type is steel, and the material is steel. Now here we have to select the H355. So just use the Eurocode here, the Eurocode. Now I'm going to define the column material. So this is the main column. Okay, here you can select the okay, so here this one for main column. Good. And so here here's 300. This is the corner column and it's also similarly in the column and just to the beam. This is the main rafter. And edge rafter. Now add I'm going to use the Australian standard in order to define the purlin. Let's see. So now let me use 200 by 19. This is for purlin. So add. Okay, now for the wall purlin, you can use Z215. This is for wall purlin. Right. So now let me use also the for bracing. So the parametric one, this one, and the solid one. It is 2.5 centimeter. Now the name is the brace. Now click it. Now scanning. Okay, now let me come to the standard rule for the Australian standard. Okay, now the Eurocode standard. Okay, now standard here. So now the rectangular cross section for the tie beam. Okay, it is 200. Now let me select this one. Sorry. Okay. So now this is for tie beam. This is for tie beam. Now click that. Okay, now all the cross sections are defined. Okay, sorry. Now close this one. Here, all the defined cross sections are coming here. Now close this one. Okay, now let me here in order to view the 3D of the shed. just you can view just like this. Now let me draw the vertical members here. Now click this button, and now just select the simple bar, and now let me draw the corner column here, the corner column here. So click this one, and this one, and click this one, and this one. And also just the edge rafter, and this one here, like this one here. So just I can copy this to the. Okay, now let me draw the main column here. So copy this one, just like this. So the X, sorry, not the X to G. This one. Now let me draw the main rafter. Okay. So draw the tie-beam. The tie-beam here. So in order to draw the purlin, first we have to divide the column at every 2-meter spacing, but at the base 25 centimeter from the base and 25 centimeter from the apex. So to do this, we have to select this column and go to the geometry, I mean the edit menu. So divide the column. So here, if as this one is, it is around it is 8 meter, so we can divide into 4 segments having a length of 2 meter. Which is 4. So here execute. So if you want to view the nodes, you can click this one, sorry, this one. Here all those are the generator nodes without dividing the column. And then here, so select this one and edit. Now divide the column here in distance. So here it is around, it is 8 meter. So from the base, so it is 0.25. So here an additional node will be generated 25 centimeter from the base, because the first wall purlin starts 25 centimeter above the floor. So here execute. Here now this node is generated, and then it is 8, I mean it is 7.75. That means 25 centimeter from the top of the column. And now execute. Here this node is generated. So sorry. So here now let me draw the wall purlin. Now here the wall purlin. The first wall purlin has to be drawn here. So you can copy this member into this member, and then this member into this member, this into this into this. Okay. You go to edit menu and you copy this one. Sorry. Go to the edit menu, copy. This one. Copy this one also to the base of the column. Okay, sorry. Here the notice have been deleted. So now control. Now let me copy all those elements to the baseline of this. Again, first here I have already this member, so I have to select this one. Then I have to paste here. So similarly, I have to copy this member to the base, and I have to copy this also to this member. Okay. And similarly, I have to also divide the rafter into the n number of segments, so that every purlin will be located at every 2-meter spacing. And also here the last purlin close to the eave of the shed must be 25 centimeter from the eave. So to do this, now let me select the rafter. Here the length of the rafter is it is 80.17 meter. So just to go to the edit menu, now divide with any number of also as it is 18.17, so now 18, these tools, just go to the calculator. So here we can divide this 18 into 2, so it is 9. It is 9. So we have to divide this into distance, into 9 division. So here execute, and similarly here this also execute. So now let me also draw the nodes where the first purlin starts. So go to the calculator. So this is 18.17. This minus 0.25. This 17.92. So the first one is 0.25. Sorry, 0.25. Here the node will be drawn here. Now click execute. Now this one, and also similarly it is 17.92. Now the node will be drawn here. Execute. Perfect. Here. So similarly here also. Okay, because it is not selected. Okay, here and 0.25. Now the node will be drawn here. Sorry. Okay. And okay, first we have to select this one. sorry, 17.92. This node will be this node is draw. So here now let me draw the roof purlin. Now here roof purlin. Okay, no, sorry. Perfect. Okay, now let me copy this one. Sorry. Okay. So now select by cross section because all the roof purlins have the same cross section, so we can select just like this. And now just go to the edit menu and the vertical mirror here. So now we can mirror as this one is the ZX plane. Sorry. Go to edit menu, vertical mirror. Here the ZY. You got the vertical mirror in the ZY plane. After selection of this operation, do you want to perform the operation for door structure? No. Okay, what's drawing here? No. Okay, close this one. Okay. Okay, it is mirrored. Perfect. So all those are the previously drawn purlin. No, now let me delete. Okay, perfect. Now let me save it. My desktop. This is still roof shed design. Sorry, roof shed. Still roof shed project. Now it is saving. Now it is time taking. Okay, now it is finished. So here now let me make the support here. The fixer support now apply. Okay. Okay, no, sorry. Here be careful that you know, when you select this node, you have to take care. So it is a fixer support. Okay. So now I have to also observe the local system of the member. So here vertical, perfect. The z-axis should be located away from the structure. Okay, you know, the z-axis is this one. I can rotate. I can rotate now. Let me in order to see the section shape, you have to click this one, just like this. Okay, now let me rotate this member. In order to rotate this member, click this one, and here the make the gamma angle, it is 90. It is 90, so it is rotated. Now right click, copy property. Now apply the property here, the property here. Okay, and similarly we have to select the purlin, the root purlin here, and you go to the gamma angle and make it is 90 degree. Okay, first now let me see how it is located. Okay, it is located perfectly, no need of rotating. Sorry, let's undo. Okay, observe the local axis. It is outside, perfect. Now it has to be click this one and 180 degree. Now gamma angle. Okay, now the z-axis is away from the shirt. The shirt. So right click and copy the property and then apply the property to this member. Okay, now okay, now perfect. It's away and it's away. Let's come to here. Okay, now rotate this member 90 degree. Okay, sorry. Click this one. This is 90 degree. Okay. Okay, sorry, it is copy the property, apply the property to this one. Okay, perfect. Here also apply the property to this wall purlin. Okay. Here, in order to you know locate the z-axis of the wall purlin away from the shed, I have to rotate the local axis of the bar. Here to do this, go to the geometry. So here okay, sorry, just go to the edit menu. Okay, where is this? The property, okay, the local bar direction. So here to the z. Okay, sorry, to the negative z. Okay, now to the y axis. Okay. Oh, no, sorry. Like this one, and copy property, apply the property. Look like this one. Control. It is 180. Gamma angle. Okay, perfect. Now let me observe the location. Sorry. Perfect. Now copy the property. Click this one, and click for this one, and click for this one. Now the local z-axis is located away from the structure. It's perfect. Now this is also perfect, and this is also perfect, and this is also perfect. This is also perfect. Okay. Here now let me apply the offset to the column. To do this, we have to select this member and this member, and also this member and this member. So I have to open to the new window for simplicity of just offsetting. Now let me observe the top view of the section. Okay. Here now this is the plan of. Okay, now located, perfect. Okay, here so the dimension of this column is different from the dimension of this column. So when I apply the wall purlin to the column, so the wall purlin must be you know flush to the faces of you know the flange. So if you know here this is the eye section, this is the center of the eye section, and also here this is also the section of the eye section. Here the section of the internal uh, steel columns. So if I draw the zipper link here, if I apply sorry if I apply the zipper link like this, so this surface, you know, here it has to be moved to the shed with the distance of x. So this x must be calculated. X equals to the dimension of this, that is the h over 2, where this is h, sorry, this is h, so h over 2 minus, this is also another h, this is also, let's say this is h2 over 2. Here this h is equal to, it is 29 minus this h is, it is around at the main column is, it is 450, it is 44, h is, it is 44, so it is around, it is 22. To the differences, it is 7 centimeters. So I have to move 7 centimeters to the shed. Okay. So to do this, I have to select this column and the geometry, and the offset. Okay. Now click the new offset definition here. So this is the main column offset, which is around 7 centimeters. So to do this, first I have to offset the upper flange. Apply. Okay, and then I have to offset out of the shed, which is around as it is 29, so it is 14.5. It is offset of main column. It is around, it is 14.5. It is 40.5, and also the end is 40.5. Now add. So here apply. Perfect. Now this flange is aligned with this flange. Okay, similarly first the upper flange, and then also to the side. Perfect. Okay, here now make it. Okay. So here now let me also offset the wall purlin, because the wall purlin should be located on the faces of the flanges of the column. To do this, now let me select one of the wall purlin and the column, the two column, and open to the new window. Okay, like this one. Here first, now let me observe the local axis here. So select the column, I mean the wall purlin, and try to move the lower flange now to out of the shed, or just offset the lower flange. Now offset, take the lower flange. This flange should be located to, okay, sorry, first I have to okay, now let me offset the lower flange. The lower flange. Okay, and then offset also this wall purlin with the dimension of from this up to this, so that this you know, flange of the wall purlin will be located at the flanges of the column. So to do this, now let me define also the new, okay, or just I can use this offset of the main column to this 40.5, just like this. So I can use this one, which is similar. No, sorry. Display and delete this offset. Display and disable. Perfect. Okay, now define the new offset, wall purlin offset. Which is 14.5. Okay. I'm gonna click this one. Perfect. No, there is something wrong. There is something wrong. Yeah. Oh, oh. T is 450. T is 450. No, it is 300. No. Okay, the problem is found. Now here, delete this one. Now let me copy this one. Mm. Perfect. Now display. And now click offset. Now apply. Here, this purlin is located over the faces of the flanges of the column. And here, this purlin is located on the faces of the flanges of the column. This is, the physical model. This is the actual, the practical location of the wall purlin. Okay, now select this one. Now here apply the properties of this purlin to all the rests. Wall purlin. Apply. 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 Here apply. Now if you display the offset, you can see clearly the location and the configuration of the wall purlin. Apply. Here, if you see, the wall purlins are located over the faces of the column. This is the perfect and the correct arrangements of the wall purlin. And now let me do also uh, in the same procedure for the left side of the purlin. Now copy this one, copy this one. Now apply the property to this purlin. Okay, now sorry. Now let me open to the new window. First select this one and offset the lower flange. Apply. And then apply the wall purlin offset. It is 40.5 to the poly. Perfect. Here now apply the properties of this purlin to all the rest wall purlin, so that the purlin will be located over the faces of the upper flanges of the column. Sorry. Copy. Now select the purlin. Now offset the lower flange. Okay, sorry. Now let me see the orientation of the local axis here. Okay, this is the problem. So this must be reversed to this direction. The local z axis must be reversed. So to do this, select this member. So here just go to the gamma angle. It is -90. So make it to -270. It is reversed. Perfect. So now offset the lower flanges of the Z purlin. Apply. And now also apply the 14.5 centimeter offset to the wall purlin, so that this wall purlin will be located over the flanges of the column. Perfect. Now it is located here over the flanges of the column. Now click OK. So exit. Here, as you can see, this one, which is perfect arrangement. Now copy the property. Apply. Okay, no, sorry. Okay, now let me also offset the rafters. So here to do this, I have to select this one and geometry, offset the upper flange. Perfect. And then now let's also offset the roof purlin, so that the roof purlin will be located over the top flanges of the rafter. So to do this, select all the roof purlin and then go to the geometry, now the offset. Hit the lower, now offset the lower flanges of the roof purlin. Here the roof purlins are located over the surfaces of the rafter. But here, if you see, the purlins are not perpendicular to the rafter, because the slopes of the rafter is 9.71 degree, this angle. So we have to rotate the roof purlin by 9.71 degree, so that the purlin will be perpendicular to the rafter. So to do this, so now let me select one of the purlin. Okay, go to the gam angle. Let me calculate the slope. Okay, the dimension, choose the dimensions, the align the dimension here from this to this. It is around 36, I think. It is around 36, so calculator. The half of 36 is 18. Divided by the 8 is 2.5. 7.2. Okay. Now shift turn off 7.2. Sorry. Press 18. Divided by 2.5. 7.2. Oops. Turn also. Composed over adjacent items 2.5 divided by 18. It is 7.91 degree. 7.91 degree. Okay, here if you see this one, okay, it is 90 degree. It is the perfect arrangements of the wall purlin. So now select this purlin, copy the property, now apply this property to all the purlin. Okay, no, okay, sorry. Then here also apply the command minus 9.71 minus 9.71. Here it is 90 degree. Okay, now let me see the local axis. So I have to reverse this local axis into this direction. The y-axis, the z axis should be reversed into this direction, so that this balloon will be a mirror of this one. So to do this, just go to edit menu, the command. Okay, now sorry, the geometry. Okay, where is this? Edit menu. Make a local direction. So now reverse the y axis. Now apply. Perfect. This will be reversed. Now copy this property to all the roof poly located on the left sides of the roof. Okay, no. Sorry. First, now let me apply the property to all the roof poly. Becoming minus 9.7. Okay, so just go to the command. So make it minus 9.7. Okay, it's perfect arrangement. So here now let me reverse it. Okay, copy this property to the rest of the purlin. You can now select. Just go to the geometry and the property and look our direction. I can apply. Perfect. Okay, now let me draw the typing. Okay, now offset the upper flange. Sorry. Okay, now let me see local axis orientation. Okay, here now offset the upper flange. Okay, the upper flange. the upper flange. Perfect. Now the top surface of the uh, the top beam will be leveled with the top surface of the column. Now I have finished offsetting the wall and the roof purlin as well as the rafters and the columns. So here, after this, I can replicate uh, all the defined member to the right of the axis. Now my PC is busy. Okay, wait for a minute. Okay, it's not coming. We can now deselect this route. So now select this one, select all the whole poly, and select the main column here. Okay, be sure that all the purlins are selected. All the purlin, all the tie beam, all the columns, and the internal main rafters must be selected. Okay, be sure. Here this member is not selected now. I may select. Okay, now. Okay. Just now, let me replicate this selected element to the right of the axis. Just to do this, go to Edit menu and copy, and here the number of copies 1, 2, 3, 4, 5 to 5. The number of repetition is 5. Okay, be sure that the lower this node is selected. Okay. Robot structural analysis software is a very user-friendly software, and it saves the time by just replicating all the defined and the drawing member to the right of the axis. No need of just to draw all the member to every axis. So this is the advantage of the robot structural analysis software. Okay, now let me copy the edge, column, and rafters. I'll go to the edit menu, add copy. Okay, here I haven't deleted the number of repetition because I have previously put 5. That is why this replication is too much. Okay, now select this purlin, this one, this one, this one, this one, this one. Be careful when selecting the member. Okay, be sure that all the members are selected. So now go to the edit menu and copy with this baseline. Delete this dimension line. Okay, now let me draw the brace. Okay, now the braces are drawn. So in order to view the bar section colors, just like this. Okay, perfect. Now this the purlins are not located on the faces of the column in this view because the offset is inactive here. If you select this one, this purlin will come to this one. Look like this. Okay, now let's draw the now let me copy this brace to the raised locations. To this baseline. Okay, let's draw the column on the gable side. That is the indie column. Now copy the empty column to the opposite side. I think the color is not good. It is not visible. So now let me convert this color. Okay, now let me draw the purlin, the wall purlin on the gable side. So just go to the tools and define the snap setting. Now select all. So now let me see the local axis location. So this should be reversed. The positive Z axis should be located away from the shed of the blocks. So to do this, select this one. And adjust the gamma angle. No. Okay, now it is perfect. Now copy. And now let me check the offset of the corner column and the in the column. Okay, sorry. Gamma angle, it is around 270 degree. Control 2. Now go to the open this to the new window so that the offset will be applied. Now rotate this into 100 into gamma angle, it is 90 degree. Now rotate this also 180 degree. Copy this and apply to this one. Okay, this perfect orientation. Okay, check this one. Copy this one and apply to this one. Okay, now let me apply the offset. Here the dimension from this to this is 300, but from this to this is 29. This is taken from the Eurocode standard of this cross section. So this arrangement is in this way, and this one is in this way. So there is an offset difference of 5 centimeter, because it is 29 and this one is 300. From this up to this 300, from this up to this it is 29. So go to the tools, calculator, it is 29 minus, it is 30, which is equal to divided by 2, which is around, it is 0.5 offset. So which column will be offset? This one. In which direction? In this direction. I mean, okay, this is 300 and this is 29 and this is out of the shade. Offset of any column, that is by 5 centimeter outward. Sorry. It is 0.5 and this one is 0.5. Okay, yes. So offset this one. Perfect. Now offset the lower flanges of the wall purlin on the gable side. No, sorry. Now set the lower flange. Perfect. So now here offset this by 40.5. No. This is in the positive direction. The wall purlin offset. This one. Oh, there is a mirror here. It is not located over the surface. There is a mirror here. Inshallah this one go message. Offset by Okay, now let me see this object property. This 29 object property. This 29. So this is 300. So now like this one. Now let me apply this property. Copy property, apply. So now display. So set apply. Okay. Undo. Okay, now here first, now let me make the lower flange offset, and we can get this one, this one is the make the lower flange offset and apply here, and the lower flange is coming to the green lines, and then to the offset here we have to offset 50 centimeter away from the shed, because the distance from the center to this point of the flange is around, it is 50 centimeter, because from this up to this it is 30 centimeter. So when we make the starting and the initial points of the word purlin offsets 50 centimeter away from the block, then we can shift this to this one. Look it when we shift to this. Perfect. Now here the lower flanges of the purlin is located over the upper flanges of the column. Now this is okay. Perfect. Okay, now let me apply this property to the rest of the column. Then apply, 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 apply. Then now copy this one. Edit. So how many times this? Okay, now because the spacing is not equal distance, so that's better if I copy one by one. Okay, no, it is not selected. Sorry. Be careful when you collect this point. So now select, okay, sorry, select this one. Now 1 2 3 4 5, which there's 5 division. Okay, so we have to copy this to opposite side. Now go to edit menu and copy. With baseline of the supports of the corner column. You know, my PC is too busy. Okay. Sorry. Sorry. Now let me copy the properties of the in the column. Now let me adjust the offsets. Here on the opposite side. So here I have to offset the lower flange. First, now let me see the orientation. Now let me revert the orientation of this. Is 270. It is 90. Perfect. Okay, no. Okay, it is outside. It's perfect. Okay. This is a good orientation of the wall purlins and the column on the gable side. Perfect. This is a good arrangement of the members. Now next times I will show you how to apply cladding on the wall and how to apply load on the wind load on the wall and the live load, the dead load, the recover load, and after that how to analyze the steel frame structures using robust structural analysis. Now for the time being, I think it is all about the modeling of the steel shed structure. So thank you very much.